So this categories end have like a kind of panoramic field of view with extremely low resolution. And my robot has a kind of similar panoramic field of view with different perspective, but with really tiny visual resolution as well. And the thing is, what kind of behavior I'm studying? I'm studying the visual homing part. To the left, you can observe that when you release a ant somewhere around the nest, they go back to the home doing visual homing and using vision only. And they can do this for visual route following as well. So they can go back and forth between the feeder and the nest and doing the same route again and again. So it's kind of considered two tasks of behavior, two kinds of behavior. And we replicate the visual homing part with our robot. So I will present this tomorrow. This work tomorrow, yes. And so you can observe that the robot was released at some point, and he went directly to the home using vision only, and a mushroom body part of the brain. Mushroom body is a part of the brain where learning happens in the hand and insect. And we did also visual route following, which has been recently accepted. So the two behavior was made with the same control rules and the same low learning architecture, but we changed only the learning rule, but maybe not the learning rule is a great word, maybe more the learning method, learning chain, and what we will use to supervise the learning. It's all about reference frame. So for the left, so for the visual homing, we categorize the views as either the nest is on the left or the nest on the right. And then we differentiate the two memories to go and steer towards the home direction. So it's a global fixed frame during learning. And for route following, it's not the global fixed frame, but this time it's a moving frame, like frame. And we take into account the direction of the route. So either we're looking left of the route or we are looking to the right of the route. So with this kind of learning chain, with same control output, that differentiation between two memories, we can have two different behavior, visual homing and visual following. So thank you. If you have questions.
Sorry.
Yes.
How does this system like adapt to the changing environments? For example, in a real world scenario.
Yeah. In fact, that really well for the visual route following part to the bottom right. We tried this system with like pedestrian moving and car moving, for example, visual cues.
Yeah, in specific, for example, if it's raining or if it's snowing.
Because of the low resolution visual system and because it takes only the edge of the panoramic views and because it takes as well the panoramic views, so it's really robust to the changing environment. At least when you have the same edges on the image. Let's see.
Okay.
Thank you.